Liquids and gases in industrial facilities are often contained under pressure in closed systems. These types of systems can remain pressurized only as long as the system is closed. And because the systems are closed, if the pressure increases excessively to a point greater than the system can stand, the equipment or piping will rupture. Excessive pressure can occur for a variety of reasons. For instance, starting or stopping equipment without proper valve positioning can result in excessive system pressure. Excessive system pressure can also occur when equipment malfunctions. For example, if a line from this pump is blocked when it should be open, an increase in pressure can occur. Excessive pressure in systems can be relieved by relief valves, like the ones on this liquefied gas tank. A relief valve consists of a valve body, a disc, a seat, a spring, a valve stem, an adjusting screw, and a lock nut. The valve body or casing provides a path for the liquid to flow and holds the other valve parts in their proper positions. This is the valve's inlet, and this is the outlet. The disc rests on the seat and is held in place by the spring when the system is at normal pressure. The valve stem guides the disc up and down, just like in other valves. A relief valve is set to open when the pressure in a system reaches a predetermined value, say 200 psi. If pressure in this system reaches 200 psi, the pressure on the disc begins to overcome the force of the spring, and the disc begins to lift off of the seat. As this happens, the pressurized fluid is released through the valve's outlet. If the pressure in the system continues to rise, the disc will continue to lift until it has risen as far as it can go. As soon as system pressure begins to decrease, the valve begins to close. And as the system pressure decreases to just slightly below 200 psi, the force exerted by the spring will push the disc back onto the seat. The adjusting screw is used to change the force exerted by the spring. Tightening the adjusting screw increases the force exerted on the disc, thereby raising the pressure setting at which the valve opens or lifts. Loosening the adjusting screw reduces the amount of force on the disc and allows the valve to open at a lower pressure. The lock nut holds the adjusting screw in position after the force exerted by the spring has been set. The top of the assembly is usually covered by a cap that protects the adjusting screw. On a piping system diagram, a relief valve could be represented by any of these symbols. The relief valve setting is often included beside the symbol for the valve. Because of the way it operates, a safety valve, like the one on this steam line, is well suited for use on steam or other gas systems. A safety valve is designed to open wide very quickly and to stay open until the pressure in the process system has been reduced to a pressure that is less than the opening pressure of the valve. Since the valve opens wide quickly, a large volume of gas can be rapidly vented from the process system to reduce pressure. Getting a safety valve to open wide quickly can be done in a couple of different ways by valves with different designs. Let's look at a typical example of a safety valve to see one way it's done. This safety valve consists of a valve body, a disc, a seat, a spring, a valve stem, an adjusting screw, a lock nut, and a manual release lever. The manual release lever is used to test the operation of the safety valve. The disc of a safety valve has a lip that isn't exposed to system pressure when the valve is closed. The center portion of the disc is always exposed to system pressure. If the valve is set to open or lift when the system pressure reaches a preset limit, say 200 psi, the disc will start to lift when that pressure is reached. When this happens, the lip of the disc is suddenly exposed to system pressure as well. And since a larger area of the disc is now exposed to system pressure, there's more force exerted on the bottom of the disc. This increased force overcomes the force exerted by the spring and causes the disc to pop open to about a 60% open position. This allows a large volume of liquid or gas to escape rapidly. If pressure in the system keeps getting higher, the pressure acting on the bottom of the disc will also increase and cause the disc to lift even higher. Once the excess pressure in the system has been relieved, the system pressure will begin to drop. As pressure goes down, the force acting on the bottom of the disc also decreases. Eventually, the force exerted by the spring takes over and pushes the disc down. However, when the system pressure gets down to the point where the valve popped open, 200 psi, the valve still doesn't close because the lip of the disc is still exposed to the pressure of the escaping liquid or gas. The valve won't close until system pressure drops below the pressure needed to pop the safety valve open. The opening pressure setting can be changed using the adjusting screw. Tightening the adjusting screw increases the force exerted on the disc, thereby raising the pressure setting at which the valve opens. Loosening the adjusting screw reduces the amount of force on the disc and allows the valve to open at a lower pressure. The lock nut holds the adjusting screw in position after the force exerted by the spring has been set. On a piping system diagram, a safety valve could be represented by any of these symbols. These symbols are similar to the ones used to represent relief valves. Often the valve's operating set point is also included beside the symbol. In this topic, we've seen how relief valves and safety valves are constructed and how each of these valves operates as system pressure changes. We also saw how you could identify these valves on piping system diagrams. Now let's try some practice questions. The adjusting screw is used to change the force exerted by the spring. Tightening the adjusting screw increases the force exerted on the disc, thereby raising the pressure setting at which the valve opens or lifts. Loosening the adjusting screw reduces the amount of force on the disc and allows the valve to open at a lower pressure. This safety valve consists of a valve body, a disc, a seat, a spring, a valve stem, an adjusting screw, a lock nut, and a manual release lever. The manual release lever is used to test the operation of the safety valve.